on the second page, which is completing the square. And let's go ahead and review our three forms first. If you are in vertex form and it's written correctly, you should immediately be able to see what? All right, the answer is vertex. It's called the vertex form, so make sure you get that one correct. Okay, the vertex is your C, D ordered pair. And like I said, most textbooks will call it H and K. And the reason they call it something different than C and D is because in standard form, ax squared plus bx plus c is your y-intercept. All right, and so you don't want to confuse you with C being the y-intercept, but then C being part of your vertex. So kudos to those other books. Our book with Carnegie didn't think that all the way through. So just know that if you hear HK, it's also the same thing as our C, D movements. Okay, and then obviously in factored form, you're going to get what? The two roots. That's correct. Hopefully you got that. All right, it's root 1 and root 2, and it's always x minus the root. So kind of like your x minus c in factored form, if it was x plus 2, your root would be negative 2 for the x number, and then 0 obviously for y. So we always want to write it as an ordered pair, negative 2 comma 0, because it's a specific point on our graph. So don't just say x equals, say what the ordered pair is, right? X-intercepts are an x number, comma 0. Y-intercepts are 0, comma a y number. Okay. All right. So now we're going to talk about the importance and the reason for completing the square. In a problem, we will have typically be given a standard form. If we're given a standard form, this we'll call S of x, we want to be able to know what that vertex is. Okay. So right now, go ahead and graph that and see what that vertex is. And when you do that, go ahead and write that vertex down. Okay. So I'm not really sure what that is. Let's go ahead and grab my calculator as well. I'll show you what I'm doing. I'm going to grab my calculator and type all this in. All right, I'm typing in y equals x squared plus 6x plus 9. I'm going to go ahead and graph it. And when I graph it, I'm going to see the parabola. It's going to look something like this, which is what you should see. Okay. Now what you want to do is find where that vertex is. The quick way to do it, go ahead and follow me now, make sure you're listening, is hit second and trace. Okay, if you hit second trace, you're going to get this screen right here. You can see it. And we want to figure out where that vertex is. Notice nowhere in this list does it say vertex, but it does say max and min. So if you looked and you remember your vertex, it was a parabola facing up like that. So it is a minimum. So we're going to show the minimum here. And when it does this, it's going to say at the top left up here, let's see right up there, it's going to say left bound. What that means is you're going to create a boundary on the left side of the vertex. So what I'm going to do is I'm going to scroll over here. You're going to see me scroll until my cursor is somewhere on the left of the parabola, somewhere on the left of the vertex of the parabola. Okay, it doesn't matter where, just somewhere, and then hit enter. And when you hit enter, it's going to create a vertical line, which is like a boundary. It's going to not look past that boundary. And then up on the right or on the bottom, it's going to say right bound. I think I said earlier on the top. It's not going to say on the top. It's going to say on the bottom, right bound. So now we're going to scroll to the right until we're past the vertex, doesn't matter how far, and hit enter again, and it makes a right boundary. And now it's only going to look in between these two boundaries right there. And that's where my vertex is. Hit enter a third time, and it's going to show us the exact vertex at the bottom. Okay, so let's go ahead and write that down. Now, it looks kind of funky because you got all these decimals in there. Don't really worry about that. Just kind of round and recognize that the vertex, let's see, where's my pen? The vertex is at the point 3.00000, which is basically 3. And 2.2 times e to the negative 12, that's really silly. It's scientific notation, but all you really have to do is recognize that that's the number 0. And if you aren't sure, go to your table and look. Oops, see, I messed up already. It should be a negative 3. Go to your table, and if you go to your table, you can see negative 3, comma 0. Okay, and the reason it's just doing it is because it's trying to get super exact. It doesn't need to be that exact. The calculator is sometimes too good for its own good. Okay, so that's where our vertex is. So the vertex form, remember, if you remember, vertex form from the last page was y equals a times x minus c squared plus d. We're just going to ignore the b for right now because it just makes it a little bit confusing. And if you always have a choice, do a over b. Okay. All right, so this c value is the y or the x ordered pair of the vertex. D value is the y ordered pair of the vertex. Ignore that bell for right now. You are not released. All right, so that means our equation is going to be y equals the a number, as we said before, is always the same number for every equation. The a number is in front of the x squared component in standard. In this case, it's just 1, so we don't have to write it. So our equation is going to be y equals x plus 3 squared, and then plus 0 on the side, but we don't need to worry about that. So our equation is x plus 3 quantity squared. That will tell us our vertex is at -3, that's the C number, and 0 on the side because that's the D number. And it matches right here. All right. But what if we don't have a graphing calculator? Okay. By the way, we can check our answer, and I recommend you do that. Go to y equals and type in parentheses x plus 3 quantity squared, like I have here on my, can you see that, on my red graph? And then go ahead and enter that, graph that I should say, and you should see the graph match up exactly, which is what you want. Okay. So that tells us we graphed it correctly, and therefore he wrote the equation correctly. So what we're going to do is we're going to practice completing the square. All right. So from our original problem, we want to think of, we want a perfect square so that we can see the vertex C comma D exactly. So we have our equation here. This is what we did. And we're going to kind of work through this process. I'm going to work through, and I'm going to do one problem with you, and then you are on your own to figure them out. So what we do is we first, when we have standard equation, we first isolate our x's. In other words, take whatever your C number is and move it to the other side. And that's why they come up with y minus 9 equals x squared plus 6x. And when we complete the square, we are going to end up putting a number right after the 6x. This is going to be ax squared plus bx. We're going to figure out what the C number is so that this part right here becomes a perfect square. And to do that, think of your box foil. A perfect square, if you remember from geometry, means all the sides are the exact same. So I want to think of rewriting this as 2 parentheses, but they are the exact same parentheses. So this is going to be x in front, which means I have to go x by x because I have to get an x squared. That creates an x squared box. If you think of your box method, I want to figure out whatever this number is right here up on the top, I'm going to highlight it right here, should be the same as this number because I want it to be a square. And according to our box rules, we have to multiply rows times column to put a number here, and rows times column to put that number here, and I need 6 in the middle. So that means obviously this has to be 3x by 3x because 3x and 3x makes 6x. So I'm going to put a 3 there and a 3 there. And when I do that, this box right here in this corner can now be figured out. Obviously, knowing our rules, 3 times 3 makes 9. So in order for a perfect square to happen, if I wrote x plus 3 times x plus 3, I would have a perfect square of x plus 3 quantity squared because 2 of the exact same thing means you squared it. But I would need to make sure I incorporate this 9 in my equation. And we can do anything to one side of an equation as long as we balance it to the other. So over here, I'm going to add that same number 9. So that's why I had a blank space right here and a blank space right here. I want to balance my equation. If I add 9 on the right, I better add 9 on the left. Now this one, in this particular problem, it was already a perfect square. So it's kind of a bad example to start with because later on they won't be perfect squares. But just know that we have to move over the C value and then work with only the X number. Think about the fast way to go from this equation to immediately know. And I'll tell you what that is in just a second. But think about how could you immediately know I want a 9 there. Okay, I'll show you how to do that in a minute. All right, then we kind of combine all like terms. Okay, we know that from what we just did, x squared plus 6x plus 9 reduces down to this level right here, which is x plus 3 quantity squared, because we go from this form to factored form, and those factors will be the exact same because it's a perfect square. We forced that to happen. On the left side of the equation, we're just going to add up whatever we have. We had a -9 to start because we moved it over to the other side, and then we added 9 to make a perfect square. So on the left side, -9 plus 9 is 0, which means here is our correct perfect squared equation. Okay, and obviously we already had this from before because it was an example problem, and we already graphed that. You don't have to write the -0 down here at the end. Oh, by the way, the reason they did that is because whatever this number here is, we're then going to finalize our process by writing it back to the other side of the equation at the end. Okay, so if you're adding 0 on one side, you would subtract 0 to get to the other end. Again, you don't have to worry about if it's a 0 because it just goes away, but if it was a number 7, for example, we'd have to have -7 on the outside. Okay, and this obviously turns into x plus 3 quantity squared, but this is our C number and our D number, so we know our vertex. So let's practice this. Okay, find the vertex for the following functions. This is non-calculator, so we got to be able to do this all one quickly way. So let's first go ahead and through the process. We're going to move over our number 22 to the other side. So we're going to get y minus 22 equals x squared minus 10x. Pause this video if you get lost or you get a little confused or you want to see it again. Okay. All right, what we are going to do is we're going to now complete the square. So I'm going to recognize that I need to have some number on both sides, put a little line there, that is going to have to complete the square. And this is where I said I was going to show you a little trick. The trick is if it's a perfect square, that means, and I have to have 10 x's in the middle, all right, when I do my little box here, the quick method is to take half of the middle number. Half of 10 is 5. So let's go ahead and figure out what that's going to be. If I took half of that, I would put 5 here and 5 here. That would mean this would be x minus 5 and x minus 5 because I want a negative 10. And I'm not going to do this box every time. I'm just going to show you how this works out. The question is, what goes in this little corner? Negative 5 times negative 5 does make 25. You're correct. So I'm going to add 25 to both sides. And I'm kind of squeezing that in, so apologize if that's the case. Now we're going to go ahead and write everything correctly. Ultimately, I'm going to add up the left side. Negative 22, if I add 25, makes positive 3. And on the right side, I'm going to write it in a perfect square because I know I have x minus 5 and x minus 5. Last step, bring the plus 3 to the other side by subtracting it. And now I have my vertex form, and I know my exact vertex. My exact vertex is C, comma, D, right there, which means for me to answer this question, my vertex is at the ordered pair 5, comma, negative 3. And if you want, go ahead and go back to the equation up here, type it into the graphing calculator, y equals, go to second trace and calculate the minimum again and see if you get 5, negative 3. You're going to work on number 2, and I'm going to flip it over to the back side. On the back, follow through how it works here if you have an A value. Okay, I'm going to do one of them. I'll do number 3 to start you off. We're going to first do the exact same thing we did before. Okay, again, pause this video if you're a little bit behind or if you want to see it again. Okay, I'm here to work with you and come in, obviously, if you're still confused. But if you have an A number, all the steps are the same with one additional one in the middle. I'm going to show you what's going on. All right, first thing we're going to do is we're going to move C over. So we're going to add 5 to the left. I'm going to put a space this time. All right, first step done. The next step is we are going to factor out the A value just from the side that has the A value. So we're going to say y plus 5 equals, we're going to factor the 3 out, close our parentheses. I'm going to make a little more space here because we're going to need to enter in the perfect square number. All right, so let's see. I'm going to put a space here. If we factor out 3 from 12 and from x squared, we're going to end up with x squared plus what number? Yes, 4 x's. And if you're not sure, always think distribute. 3x squared makes 3x squared. 3 times 4x makes 12x. And then this is where the completed square comes in. We're going to put our blank right there. Okay, and that's obviously going to balance over here. The hard part's done. Now it's the exact same as what we did before. What number would we need here to complete the square? If you want to go ahead and draw your box and figure out what number that is, go ahead, pause this video. I'll give you a second. All right, we're done. We're back, I should say. All right, what number did you put there? Hopefully you put 4. I'm going to show you how I know that really fast. The fast way to do this is take half of the middle number. The middle number is your 4x, so it's the 4. Take half of that, it's 2, and always square it. Half of 4 is 2, square it, I get 4. Now, if you followed me, you probably wrote plus 4 here and plus 4 on the other side. And that's a common error because when you have an A number, this 3 in front right there has to still be multiplied by that. So really, don't put 4 here, do 4 times 3 because when we factored that 3 out, the parentheses means everything in the parentheses must multiply by that A number of 3. So really, I'm going to be adding 12. It's this number times the A number. Now I'm done, and now I just put it all together. All right, on the left side, let's combine like terms. If I add a plus 5 and a plus 12, I get 17. On the right side, leave A alone and write everything else with your perfect square. X plus, and it's always the half of the middle number, 2. Last step is to rewrite your equation correctly. Move 17 to the other side. 3 parentheses x plus 2 squared minus 17. And now my vertex is staring at me. Negative 2, negative 17, and I'm done. So on this problem, my vertex is negative 2, negative 17. Put it as an ordered pair because that's how we write points. All right, you're tasked with finishing number 4 and then picking up when you're done with that, the evaluate 3 forms of a quadratic. Work with your groups. All of that needs to be turned in. I have the answer key still, so don't just copy it, but make sure you're doing it well, okay? Check obviously number 2 and number 4 on this page at the desk with the sub. pick up the Evaluate 3 forms, work on that with your groups. Anything that you have trouble with, come see me, write me an email, do whatever you need. I'll be here tomorrow, Tuesday in class. I take that back. Quiz will be on Wednesday in class. Okay. And then when you're done with all of that and you turn in the Evaluate forms, pick up the homework page. It's a green and white stapled page, and practice as much as you can. Again, come in for tutorials if you need help. Retest will be October 15th. Check those emails. Sign up for Khan Academy if you haven't. And then quiz next class period. All right. See you guys. Good luck.